Okay, so this is what we've seen in the previous video. So what we're going to do now is I'm going to introduce you to the concept of a variable. So I'm going to redo the same example you're seeing right now, and I'm going to use what we call a string variable. So that means a variable of type string to print this hello world using this technique. And then I'll expand that to other kinds of variables that represent, for example, numbers, characters. And what I mean by numbers, that could be whole numbers, float numbers, right? Real numbers. All right, so let's get started. So I'm going to leave this one alone. We can leave this tab here and create a new one. So I can go ahead and say File, New, Source File, and I'm going to call this one example2.cpp. Now here's what I like to do sometimes is I like to write a comment at the top of the file, okay, with the actual file name. So this will be example2.cpp. .cpp will be the extension for this file, okay? So let's go ahead and save that file now. So I can go ahead and say save, and I want to save it in the same directory where I have intro to programming, where we've seen example 1. This will be example 2. Now, I do not need to type .cpp here because the extension is right here, save as. So it will automatically do that for me, okay? So now I'm going to have two source files, one example 1, and the next one is example 2, okay, for this lesson. So under example 2, I could also write a comment here that says, what do we want to do with this file? So this is, again, called documentation. Suppose I have thousands of lines of code in this program. I would like at the beginning, at the intro, write some sort of an abstract or some sort of an intro that says what is the objective of this source code. So when you compile it and you run it, you know what to expect out of it. This one will be introduction to variables. Okay, and I'm going to keep them simple. For this video, we're going to look at variables. In the next video, we're going to look at variables again, but we're going to look at them from a memory point of view. How does your computer see them? Okay? So let's start with the same typical program we had here. So we need to have the include IOStream. We need to have the using name std, and we need to have the function main with the return 0 at the bottom. So I'm going to rewrite that again, okay? I could have copied and pasted, but I need you to go and rerun this video again and do it step by step as I type this. So initially what I want you to do is watch the whole video, stop when you're done, and redo it, step line by line, okay? So IOStream, and if I make any mistakes, do make them so you can actually see how that mistake works for you, even though I will describe later on how to fix it, okay? And notice the next line will be using namespace. And then I'm going to need my int main. Now it's a function, so you need these parentheses, open and close parentheses. And then I need curly braces. And I need an open curly brace and a close curly brace. And inside, my last instruction will be return 0. Okay? So at this stage, I'm ready to compile this program. Now, if I didn't have main, this program will not compile. To prove the point, let's suppose I did not have main. So I am going to do this, and do this. Let's say I had return, or not even return 0. Here you go, right? And I try to compile this program, right? So it's already saved. Let's go ahead and save it again. Just you could see by saving it, nothing will happen. All right, so new news is good news. Now, what happens if you try to compile it? Okay, you get a warning here, an error that says there's no main in here. It's missing main. Okay, well, let's suppose I write int main and I forget to define it. And I compile it. Then I get an error. You have to define main. So let's say I define it without return 0. Now, that would be fine, except it's expecting an integer at the end. So compile, okay? As you can see, it's fine, but it's not correct. You need to complete this because it's expecting an integer as a return value that main will return back to the operating system. Basically, it's going to return this 0 value back to the operating system. What do I mean by that? When you run a program, what happens is the entry point to the program is right here. And the exit point will be right here. Okay? Fantastic. So now, let's get to the meat of our presentation for this video. I want to declare a variable of type string that I could actually type something in it, right? So hello world. So can I do something like this? String my greetings Okay, so let's compile this for a second just to make sure this is not a syntax error, which the compiler accepted it. All right, so it is within the realm of the language for C++. And let's try to understand what I just did. What I have here, my greeting, is my actual variable. I could have named it anything I want. This is what I want to store in it. A string. Hello world. But since it's a variable, I must tell the computer or the operating system what kind of data it is expected to store. Well, it's supposed to store a string. This is why the data type has to be written before the variable name. So data type, variable name, and then the value. Could I have done it like this? Semicolon. Notice every instruction ends with a semicolon. String my greeting. Great. So right now I've declared a variable called my greeting, but I haven't put anything in it. Let me compile it, just show you. Everything is good. Now, can I assign a value to it later? Absolutely. My greeting equal hello world. So you don't have to initialize it. You could assign a value later on. So again, the first method that I used was called initialization. This here is called simply an assignment. So make sure you put your two quotes to finish up the string. So it's considered one chunk of data that is stored under my greeting. So let's compile this again. So I'm compiling to check for errors here. Now, if I try to run this, nothing will happen because I'm not doing anything with this. So if I run it, notice nothing happens. Now, by the way, it's probably a good idea to write system and pause here and a semicolon to hold the screen. So let's see what happens with that. So I'm going to compile and run. And there you have it. So I have a press any key to continue. Okay? Now, great. So I want to display this. Can I display it out to the screen? Sure you can. See out. Now remember we had hello world here. So we don't need this anymore. So we're going to use the variable itself, my greeting, and then end-l. So notice the syntax here. I could use the variable name. Do not put two quotes around it. If you do, you're simply going to get my greeting as an output, not what's in it. Okay? I'll make that mistake on purpose in a minute. So what did this replace? This, compared to example 1, replaced this line. So it is in lieu of putting the actual string on the stream right here. So now we can use a variable on the stream since it already has a value, right? So we're reading the content of the variable and displaying it to the screen. So let's compile and run and let's see if it does it. And sure enough, here's hello world. Okay, I'm surprised that I can't set the properties to make this a little bigger. I guess that's about as big as it will get here. Okay. I'll see later on if I can make some adjustments for the console to be a little bigger than what I have here, okay? All right, so what if I put two quotes here? Now that, if you do that, then this becomes what we call a string literal. This here is a string literal. It is not a variable. So again, what is a string literal? This hello world here in the example 1 was a string literal. A string literal. So just in case you're worried about how to write it or how to spell it. But if you do this, watch what happens. So compile and run. Then you get my greeting. So you get the variable name instead of the variable content. But that's not the intent. We want the variable to do its job. We want to be able to put something in it. Now, can I change the content of my greeting and type it again? Absolutely. That's why it's a variable. Variable means it can change. So I can say something like this, my greeting, and I can assign it a new value. Okay? I am fine. Right? So let's see how that works. Well, first of all, you need to print it out to see if indeed the content of my greeting changed. So see out. My greeting. And then end L to end the line. So now let's see how this works. So I'm going to compile and run. And as you can see, the first value for my greeting was hello world. The second value for my greeting is I am fine. Okay? All right, so what's the lesson out of this? Is that you can change the values stored in a variable. That's why they're called variables. Okay? Can we do this with numbers? The answer is absolutely. So, can we declare a variable that holds a number? Yeah. So, you might be tempted to write number. No, don't do that in C++. So, numbers come in different formats, right? So, you have what we call integers, which are whole numbers. And even integers come in different flavors. You have long integer, short integer, okay? And then you have floats, which also come in different flavors. You have floats, and then you have double, okay? And then you have some variations of that. So let's do something with double, all right? So double, okay? And in the next videos, we're going to see how much memory space a double or a float or an int or a string occupies in memory, right? Right now, we just want to get the concept, what a variable is, how to manipulate it, and how to use it, okay? So let's say I call this one my num, okay? And that means, could I assign a value to it? Absolutely. Can I say my num equals 9, 0.1? Yeah, sure, why not? Because it's a real number. So double is a real number. It's not necessarily an integer. Okay? So decimal point is a good idea. Even if it was 9, you would write 9.0. Will be probably a good idea for you. Set some precision. So can I print it? Yes, you can print it anywhere you want after that. You could print it right in here if you want. Okay? Or you print it by itself right here. So see out. My num. Again, do not put my num between quotes, otherwise it will print simply my num. And L. Now, let's see what we get out of that. So let me just make sure I don't make a mistake here with the syntax. Let me compile and run. And there you have it. So hello world, I'm fine, 9.1. Now, can I combine all of this stuff into something a little more meaningful? Yeah, we could do that. So let me do an example where we're going to put a name, first name and last name, and age, right? So we're going to do something a little more meaningful than this, now that we've seen how this can be done. And we're going to use age as an integer. So I'm going to do example 3. So I'm going to click here for a new source file, and I'm going to call this one example3.cpp. And this one, again, explore variables in C++. Okay, so this is again part 2 of our video series. Okay, so include IOStream using namespace std. Now we're going to write a small app that will be a little more useful. Okay. And let's do a system pause here to hold our screen. Let's go ahead and do a return 0. Let's go over here and create a few strings. So one will be string first last. Now, what did I just do here? This is a list of variables of the same type. I want a variable called first, and I want a variable called last of type string. You can do that. So you could do this, or you could do this. Semicolon, string, last. So you could write them one at a time, or you could write them all in one line. I like the previous version that I had, so comma to separate them. Don't put a semicolon here, all right? Because semicolon is the end of that specific instruction or that specific line. So comma basically means I have another item, which will be last, or you could say last name. So some people like to name their variables like this. First name, comma, last name. Some people like to name their variables like this. First name, comma, last name. Notice always start with a lowercase for variables, okay? What you do in the middle is fine, semicolon. So I'll leave this one, right? I could have done first and last, or first name, last name, right? Okay. So I need you to consult your textbooks to find out what is the naming convention for these type of naming conventions for these variables, right? Right? Okay, you'll find them very interesting. So I need something else for age. Int age. Right, so now I can set values for these. So what I did here is what we call variable or variables declarations. So this is what we call the declaration block. Block means a block of code. So I need another block of code here. Assignment. Right? So this will be assignments. So what did I say declarations? Because I have each line is a declaration. Assignments is when you give values to things. So first name and John, last name, Glenn. I think it's two N's for Glenn, yeah. And then semicolon. So there. How about age? Age, I don't know how old he is. I would say about 78, maybe. Maybe not. Let's suppose that was the case. So as you can see in this assignment block, I was able to give values to these variables. Oh, by the way, I need to save my file just in case a boo-boo happens. My computer freezes or something like that happens, you lose all the code. So always a good idea to save your file before you get too involved. So example 3.cpp. So save. By the way, we can compile at this stage just to make sure we didn't make any mistakes or syntax errors. Even though if I try to run it, nothing will happen, by the way. Notice I have 0 errors, 0 warnings. So that means my syntax is correct for what I'm doing. So if I try to run this, as you can see, I'll just get the press any key to continue because I haven't done anything with the console or print out to the console or print out to the video. So now, typically in a C or C++ program, you'll have another block for processing. We're not doing that. I'm going to skip that one. And I'm going to have my final block. It will be for output. Now, the reason I wrote these blocks is this is typical to how you would write a program in C or anything within a single function like in main. So you can start with something, give it values, process it, like let's say you want to add two numbers, and then output the result afterward. So this would be a typical rhythm, if I should say, on how a typical program might work. So you have inputs to a system, right? But you need to define what these inputs are. That's what the declaration are for. The assignment is when you give values to these inputs. The system processes them, and then it will have an output or several outputs to spit out the result of processing the values that you've just put in. The processing will be where your algorithm will be or whatever function this main function is supposed to be doing or the job. But in our case, we're not doing anything with processing. For this case, we're going straight to output, okay? And notice 2 slashes always means it's a comment, okay? So in my case, I am going to output, and I'm going to make this one interesting. This is where streaming comes in handy. I could do something like this, name, and I'll put a /n here. No, I'll just put this, and I will attach first name to this. So first name, and then I will stream a space between them. Okay, so is everybody starting to get it here? This is a trick, neat little trick to format your output. So this is what the streaming to the console allows you to do. You can combine string literals with string variables. So last name, and then what I'm going to do here, instead of an endl, I'm going to do a /n. A /n is called an escape character. This allows me to get a hard return on the console, to give me a new line, basically. And notice I'm not going to put a semicolon here. I could, and if I do, I'll have to rewrite cout again to print the age. But this allows me to keep streaming. So if you're going to do that, you can actually hit a hard return here, just for clarity, and put age here. And then stream that too, age. Now you can end all of this, endl, like this. This is the end of the line for the whole cout statement. Now let's see how this behaves. Now we can run this and see how it works. So compile and run. And there you have it. It's formatted the way I want it to. Okay. So name, John Glenn. Enter, which is a hard return, right? That's your /n. Then age goes on to the next line. So it actually prints a string literal, age and the equal sign. And then it prints the content of the variable 78. Fantastic. So for the next video, we're going to delve into a little deeper into these variables. We're going to see what really is going on with the computer. How is it storing these variables? Okay? And that's where we're going to learn about the stack, the heap, and memory locations. Great. I will see you then.